Okay, so hello and assalamu alaikum. Today we have here Cambridge IGCSE paper 2, May June 2021, variant 2 extended version, total time for which is 45 minutes and total marks 40. Question 1. A gas is released at point P in the apparatus shown. The apparatus is given which gas turns the damped universal indicator paper red most quickly. So this indicates the real question is which gas diffuses faster because each of these gases will change the color of the universal indicator. So they're basically asking which gas makes it first to the indicator. So the rate of diffusion depends upon the MR of the gas. So the MR is inversely proportional to rate of diffusion. So the higher the MR, the lower the rate of diffusion. The heavier the gas, the slower the diffusion. And there's one other aspect to this question as well. We'll look into it in a minute. So the MR of ammonia should be 14 plus 3, 17. Chlorine should be 35.5 times 2, which is 71. 71. Hydrogen chloride should be 36.5. Sulfur dioxide should be, mm, it should be 32 plus 32. So this should be 64. So technically, the answer should be A. But the thing is, ammonia is a basic gas. It does not turn the universal indicator paper red because it is a basic gas. It turns it. So we want a gas which is acidic. So hydrochloric acid is the acidic gas and it will travel faster than this also. Next, a mixture of colorless compounds is separated using chromatography. Which type of reagent is used to detect these compounds after separation? So, a dehydrating agent, there's no reason, absolutely. We don't need to dehydrate. A locating agent, the most common sense answer, because to locate where each of the substances. Which statement about paper chromatography is correct? A solvent is needed to dissolve the paper. We don't dissolve the paper. Paper chromatography separates mixture of solvents. No, it separates solutes, not solvents. The solvent should cover the baseline. No, the solvent should be below the baseline. If this is the paper, this is the baseline, the solvent should be below the baseline. The baseline should be drawn in pencil, yes, so that the ink does not interfere with the with the solvent. So question 4, element X has 7 protons, element Y has 8 more protons than X. Okay, so element Y has 15 protons. So the number of electrons in the last shell of X is 2, 5. So 5 electrons in outer shell and in Y 2, 8, 5. Again 5 electrons in the outer shell, so same group but different period. Different period because the number of shells are different. 3 shells and 2 shells. So the period depends on the number of shells. Okay, so let's read the options. Y has more electron shells than X. True. Straight away. All others we have discussed why they're incorrect. A covalent molecule Q contains only 6 shared electrons. What is Q? 6 shared electrons. So 6 shared electrons. Okay, so let's draw each of them. H, H, H. So 2, 2, 2. So 6. So option A is correct because each bond represents 2 electrons. Information about 4 substances is shown. The melting point and electrical conductivity are given. EFGH are graphite, polyethylene, sodium chloride, and silicon oxide, but not in that order. Okay, so the highest melting point should be of silicon oxide because it is a giant covalent structure, so 3500. But the thing is that conducts when solid. Silicon oxide cannot conduct electricity when it's solid. So this is not silicon oxide. This can be silicon oxide because the melting point is high enough, above 1000, and it does not conduct electricity when it's solid, potentially. So, and if you look at F or G is melting point is 120 and it does not conduct electricity at all. Okay, so this should be, hmm, let's move on further. 801 conducts is the melting point and it conducts when molten. So this should be ionic bonding and a pretty high melting point, so NaCl. H is NaCl in what? In only the last option and A. So either A or D is the correct answer. And uh, E we decided should be what? Should be um, silicon oxide because it cannot be graphite because graphite conducts electricity. That is why we use it in electrolysis. So graphite is not the correct answer. A is thus incorrect. E or B or C it is not correct because H is this and E is sodium chloride. So sodium chloride cannot have a higher melting point than silicon oxide or graphite because they're giant. So B is incorrect because of this. E, now polyethylene E does not conduct when solid and G does not conduct. So this is incorrect because G conducts, graphite conducts. So G cannot be graphite. So thus option D is correct. Chemical compounds formed from a group 1 element and a group 7 element contain ionic bonds. How are the ionic bonds formed? So electron transfer takes place and the transfer takes place. These are the cations. So electrons are donated by the cations to the anions. So electrons are shared. No. Electrons are transferred from group 7 to group 1. No. From group 1 to 7. Electrons are lost by group 1 atoms and group 7. No, not by group 7. Electrons are transferred from group 1 to group 7. Correct. D. Some information about particles PQ, R, and S is shown. Which two particles are isotopes of the same element? So they should have the same number of electrons, same and different neutrons. So different neutrons. So if we look at P and Q have different neutrons, different nucleon, same electrons. Okay, and P and S. Sorry, this is P and S. P and Q have different nucleon, number of neutrons different, but different number of electrons, so not isotopes. P and S are the isotopes because in different nucleon, different neutrons, and same electrons. So B is the correct answer. Chlorine gas will react with iron metal. Exactly 21.3 gram of chlorine reacts with 11.2 gram of iron. How many iron atoms react with 30 molecules of chlorine? Okay, so with 30 molecules of chlorine, so we'll have to calculate the number of moles in this. Number of moles will be 21.3 over 35.5. The MR, but it should be doubled because Cl2 it exists as Cl2, so the number of moles are 0.3. 0.3 moles of chlorine react with 11.2 grams of iron. So if there are 30 molecules of chlorine, they should have a mass of 30 multiplied by 21.3, 30 times 21.3, so 639 divided by 71 times 30, so 0.3, still 0.3, yes. So and how many iron atoms react? So let's do it again. Fe plus Cl2 is Fe Cl2. Fe has 2 plus charge. Okay. Now 21.3 gram means 0.3 moles of Cl react with 1 mole of Fe. And if we look at the MR of iron, iron is 56. 56. So iron is 56. 11.2 divided by 56. So 0.2 moles of iron, just for the sake of it. Now, if we calculate the number of molecules of chlorine in this, if we calculate the number of molecules of chlorine in this, there will be the formula moles equals to Avogadro's constant, the formula involving the Avogadro's constant, if we apply that. But there's a smart way of going about this, a smarter way. Look, this was one molecule of chlorine, right? And now what we want is 30 molecules of chlorine. So if one molecule of chlorine reacted with how many ions? It reacted with um or let's do this in terms of moles. 0.3 moles of Cl2 reacted with how many moles of iron? 0.2 iron. And now what we have, and this was in one molecule. So in 30 molecules, if we multiply this by 100, the 30, for 30 what we did was we just multiplied this by 100. So 30. And in this, what we're doing is we'll do the same. Multiply by 100 in this case also. So 20. So there's a longer way to go about with the equations and the Avogadro's formula, but this is a pretty smarter way to do it. So this, okay, so in separate experiments, electricity was passed through. So C is the correct answer. In separate experiments, electricity was passed through concentrated aqueous sodium chloride and molten lead 2 bromide. What would happen in both experiments? So electrolysis question. A halogen would be formed at the anode in both the cases. So why not? Why not? Aqueous concentrated means that chloride is given the preference over the OH minus anion present due to water. So chloride will be discharged, and molten lead 2 bromide. So this is molten. There is no OH minus ions. So there both Br minus and Cl minus are what? Anions. So they will be deposited formed at the anode. So option A is correct. A metal would not be formed at the cathode because sodium does not discharge instead of H plus. H plus is preferred, not sodium. So metal would not be formed in this case. Hydrogen would be formed at the anode. Hydrogen is a cation. It is formed at the cathode. Hydrogen would be formed at the cathode, not in both cases. In the lead 2 bromide, there is no hydrogen ion. Okay, next. A reaction involving aluminum is shown which values of X and Y balance the equation. So just balancing. Al, if we add X as 2 and Y as 3 and X as 2 again. So what are we getting? 2 threes are 6. 6 hydrogens, while we have 12 hydrogens over here, so not correct. If you look at 3, 2, just balance, let's balance the equation ourselves. Plus 6H2O will produce AlOH3. Now, we have 12 hydrogens on this side, so we should have 12 hydrogens on the right side as well. So 4 threes are 12. Next, now we have 4 aluminum on the right side, so we should have 4 aluminum on the left side. So X is 4. So X is 4 in only option D. Option D is correct. As for Y, so if we put this 3, so 3 twos are 6 and 6. 6 total 12 oxygens, and on this side also 12 oxygen. So D is the correct answer. Next, the four different fuels are used to heat a beaker of water for the same amount of time using the apparatus shown. So there's this apparatus. The initial temperatures of the water and the temperature after heating by the fuel are recorded. Which fuel releases the most energy? Oh, so it's pretty simple. The highest temperature change will indicate the highest energy release. So 17 minus 46, 46 minus 17, the energy change over here is 29. Next it is 28. Next it is 26, 35. Next it is 62 minus 30, 32. So option C seems to be the correct answer. Option C is the correct answer because the greatest energy change is observed in C. An excess of calcium carbonate reacts with dilute HCl. The volume of carbon dioxide produced is measured. The results are shown as experiment 1. The experiment is repeated with only one change to the reaction condition. So the results are shown as experiment 2. Okay, so in experiment 2, as you can see, the yield of carbon dioxide has increased. More carbon dioxide is produced after the reaction has decreased. So, and the rate of reaction, by the way, is looking to be the same. So only the volume of the product is increased. So anything affecting the rate will not be the correct answer because the rate, the gradient, the slope is the same. So concentration affects rate, incorrect. Mass does not affect rate. Powdering the calcium carbonate affects rate, so incorrect. Now the thing is that already calcium carbonate was in excess. So, meaning that even after the reaction is complete, there will still be extra calcium carbonate left. So, if we increase that calcium carbonate mass, it wouldn't affect any of the yield. The yield is affected with HCl, not calcium carbonate, because it is already in excess. So, the volume of acid is increased, which will affect the yield. Mass of calcium carbonate increase does not have an effect because already an excess is present, meaning it is already extra, not of any use. Next, when sulfur is heated, it undergoes a dash change as it melts. Of course, this should be physical. Further heating causes the sulfur to undergo a dash change and form sulfur dioxide. So the substance is changing itself, a compound is being formed, so chemical. So option C is correct. Physical, chemical. Four statements about the effect of increasing temperature on a reaction are shown. The activation energy becomes lower. No. The particles move faster. Yes. The activation energy does not become lower. In the case of temperature increase, it only becomes lower when a catalyst is added. The particles have energy above or equal the activation energy. The activation energy itself is not reduced. There are more collisions between reacting particles, correct? There are more collisions which have energy greater than the activation energy, yes. So 2, 3, and 4, option C is correct. An example of a redox reaction is shown which statement about the reaction is correct. Zinc is the oxidizing agent and it oxidizes copper. So if zinc was the oxidizing agent, it should have been reduced because if something is an oxidizing agent, it is itself reduced. But we can see that zinc is being oxidized. So zinc is the reducing agent. Zinc is a reducing agent and it should be reducing. A reducing agent does not oxidizes, a reducing agent reduces. So D is the correct answer. When bismuth chloride reacts with water, a white precipitate of bismuth oxychloride is formed. The equation for the reaction is shown. The reaction is in equilibrium, which change causes the white precipitate to dissolve. Okay, this basically means which change causes the reaction to move backwards because when the precipitate dissolves, it is forming aqueous chloride. So backward, what moves the reaction backwards? Okay, so adding acid, yes, because if we add acid over here, we'll increase the concentration of H plus ion, so the reaction will move backwards. So one, yes. Adding water, no. If we add water, the reaction will move from in this direction. Adding sodium chloride solution. Sodium chloride solution would increase the chloride ions. So yes, this seems to be correct. 1 and 3. B is the correct answer. 18 element X forms an oxide that neutralizes sulfuric acid. So this should be a basic oxide and X should be a metal. because metal formed basic oxide, non-metal forms acidic oxide. So element X is a metal, nature is basic. Information about the solubility of salts is shown. Chlorides, aqueous solution of, uh, let me just read the question. Aqueous solutions of which two compounds would produce a precipitate when added together? Okay, so this you should be knowing yourself too. So barium nitrate reacts with calcium chloride, so this will produce barium chloride. So barium chloride is insoluble, but no, it is not insoluble. Sorry, barium sulfate is insoluble. Silver chloride is insoluble. Silver chloride and lead chloride is insoluble. Nitrates are all soluble. Sulfates, only barium and lead are insoluble. So this produces barium chloride and calcium nitrate. So no precipitate. This produces zinc sulfate and copper nitrate. Again, no, nothing is insoluble. Option C produces sodium sulfate plus NaCl, both soluble. Option D produces lead sulfate and magnesium nitrate. So lead sulfate is insoluble. Now, how do I know which reacts and which forms? The thing is, this is positive, this is negative, this is positive, this is negative. So the positive reacts with negative, the positive reacts with this negative. The equation shows the reaction between hydrogen and oxygen. The bond energies are shown, which row shows the energy change and the type of reaction. Okay, so we'll have to calculate the energy change. 2 times 436 plus 495 minus 2 OH two OH bonds. So 2 times 463 and a further 2. So basically 4 times 463. If you calculate this, this will come out to be 485. Yes, 485. The formula is energy absorbed minus energy released. So this is why we did this. 485 is the answer, and minus 485 basically that is the answer. So the reaction should be exothermic. If I'll double check, 436 plus 495 minus 4 times 463. Yes, minus 485. So the enthalpy change is negative, thus the reaction is exothermic. Burning fossil fuels releases sulfur dioxide, which leads to acid rain. Which ion in the rainwater cause it to be acidic? Obviously, hydrogen ions are what make an acid. Which statements about the trend shown by the elements of period 3 in the periodic table is not correct? The elements become less metallic across the period. This is true. And we want a false statement. This is true because there are metals on the left side of the periodic table, and as we go on the right side, there are non-metals. The group number increases across the period. This is a basic fact. The group 1, 2, 3, 4, it increases. The number of electron shells increases across the period. This is incorrect because in a period, the number of shells are same. In period 3, all elements will have 3 electron shells. In period 2, all elements will have 2 electron shells. And the number of outer electrons increase across the period. This is true, so not our desired option. 23. The diagram shows the positions of elements E, F, G, and H in the periodic table. Which statements about elements E, F, G, H are correct? E has a higher density than F. Density in density down the group 1. This is the trend you need to be knowing, and density across or around down the group 7. This is a trend you need to be knowing. The density increases. The density down the group increases. The density down the group increases in both cases. So E has a higher density than F. No. E has a higher melting point than F. Well, now another trend is being involved. The melting points. So down the group over here, the melting and boiling point increase, and over here down the group, melting point decrease. So E has a higher melting point than F. Yes, this is true because down the group, there should be a lower melting point. So 2 is correct. So if 2 is correct, G has a darker color than H. Fluorine, chlorine, bromine. So this is chlorine and this is bromine. So this is reddish brown, this is pale green. So I think H should be darker. H should be darker, yeah, reddish brown. G has a lower, and if even if we're not sure about this, we'll read 4 and we'll be sure. G has a lower melting point than H, of course. The melting point increases down the group, so the substance which is above will have a lower melting point than the substance below. So this is for sure correct. So this is why it helps us to eliminate the statement 3. Option D is correct. When aqueous iodine is added to a solution of vanadium ions, V2 plus the V2 plus ions each lose one electron. Which property of transition elements is shown by this reaction? Okay, so the V2 plus ions each lose one electron. This means that this is actually V plus, because when a substance only loses one electrons, or no, wait, this was V2 plus and it further loses one electron. So it should be now V3 plus. So two different oxidation states are present, two different charges. So option A is correct. Transition elements have variable oxidation states. A piece of aluminum is dropped into HCl, no immediate reaction is observed. Which statement explains this observation? Aluminum does not neutralize acids. Well, this is not an explanation. Aluminum is a non-metal. It is not a non-metal. Aluminum is below hydrogen. No, it is above. Aluminum is covered in an unreactive oxide layer. True. Aluminum oxide a layer is formed, an impermeable layer is formed, so no reaction can occur. Some metal nitrates and carbonates decompose when heated strongly. Metal Q has a nitrate that decomposes to give a salt and a colorless gas only. The carbonate of metal Q does not decompose when heated with a Bunsen burner. What is metal Q? So QNO3 will give us what? QO, or if you look at the second statement, the carbonate of metal Q does not decompose when heated with a Bunsen burner, so it cannot be decomposed thermally. So it cannot be copper. It cannot be copper or zinc for that matter. Now, if it is calcium nitrate, it decomposes to form calcium oxide plus oxygen plus NO2. So, how is this correct? How does this fit in? And as we know, nitrogen dioxide is a brown gas. So this is not correct. Sodium nitrate, when it decomposes, it forms a different product. Sodium nitrate, when it is heated, it forms sodium nitrate. When it is heated, it decomposes to sodium nitrite plus oxygen. So colorless gas and salt. This was a base. So sodium is the correct answer. Difficult one indeed. Aluminum is extracted from its ore by electrolysis, which equation represents the reaction that occurs at the anode during the electrolysis. At the anode, there should be the anion. So there should be a reaction of oxygen, and oxygen is an anion, so it does not gain more electrons, it loses electrons. So option C is correct. Mild steel consists mostly of iron. Mild steel can be prevented from rusting by a process called galvanizing. Copper is not a very strong metal. However, if it is mixed with a suitable metal, a strong alloy called brass can be produced. Which statement is correct? So galvanizing is done through zinc. Zinc is galvanized on iron to prevent, yeah, to prevent what? Rusting. Okay, so this is a fact. Copper is mixed with zinc to produce brass. If you know, you should be knowing alloy composition in your syllabus. So brass composes of zinc and copper. and this is not true. Copper does not corrode very quickly, and galvanizing steel does not changes from a pure metal into an alloy. Steel is already not a pure metal. It is already an alloy. When a steel object is galvanized, this means it is coated with a thin layer of zinc. Water is used for the irrigation, for crops, for drinking water, for which uses must water be chlorinated. For irrigation, we don't need to kill the bacteria. For drinking, we need to kill the bacteria, and chlorination is basically killing the bacteria. So option C. Which natural resource cannot provide a raw material for the manufacture of ammonia? Okay, so ammonia we need N2 plus H2. So this is from unburned, from hydrocarbons, and this is from air. So petroleum is basically uh, a hydrocarbon. It contains hydrocarbons, so we can use this to obtain hydrogen. Air for nitrogen, and water contains hydrogen, so water can be used for hydrogen. So the only option we have is B. Calcium carbonate has nothing to do with these two substances. Ammonia is made in the Haber's process. Which conditions are used in the Haber process? So this is purely recall. Pressure is used 200, yes, temperature is 450, catalyst is iron. You should be remembering this. This is the other way around. Which process in the carbon cycle is, this is no longer in your syllabus directly, is responsible for removing carbon dioxide from the atmosphere. So we know this is photosynthesis. Photosynthesis is in your syllabus. So photosynthesis, carbon dioxide is used and glucose is used. Sorry, carbon dioxide is, oh, sorry. My bad. Uh, the equation for photosynthesis is C6H12O6 plus 6O2 to produce 6CO2 plus 6H2O. This is not photosynthesis, this is respiration. Photosynthesis is the complete reverse. Okay, photosynthesis is the complete reverse. And what it does is it is 6CO2 plus 6H2O to form glucose and oxygen. These products. So this is what the reactant in photosynthesis. So photosynthesis needs carbon dioxide. So definitely it gets carbon dioxide from the atmosphere. So yes, it is the correct answer, but I think I was writing the incorrect equation. Next, the equations represent two reactions P and Q of lime. In which processes do the reactions occur? Okay. So calcium silicate is formed and silicon dioxide is purified in extraction of iron, and sulfur dioxide is removed in flue gas desulfurization. So B should be the correct answer. Flue gas desulfurization basically means when fossil fuels are burned, sulfur is produced to remove the sulfur. This happens. Which statement about ethanol is not correct? Ethanol can be made by fermentation. This is correct. Ethanol is oxidized to make ethanoic acid. This is also correct. Ethanol reacts with oxygen exothermically, making it a good fuel. Next, we should read ethanol reacts with propanoic acid to make propyl ethanoid. Definitely incorrect, because this name is from the alcohol and this is from the acid. So the acid used was propanoic, so it should have been propanoate, and this should have been ethyl. So this is correct. Which pair of formulae represents two alkanes? Okay, so both should be alkanes following the general formula 2CnH2n plus 2. So this is an alkane, but this is not following the formula. This is not following the formula. This is alkene. Well, who is following the formula? Yes, okay, option A, CH4 and C8H18, 35A. Which statement about alkanes is correct? They burn in oxygen. Yes, it is correct. All organic compounds burn in oxygen. They do not contain oxygen, they do not contain double bonds, they do not contain ionic bonds. Which statement about ethanoic acid are correct? It is a strong acid. No, it is a weak acid. It reacts with ethanol to form an ester. Yes, it does. It has a formula CH3COOH. Yes, it does. 2 carbon atoms. So 2 and 3 are correct. Option C. The flow chart shows how petroleum may be turned into a plastic. What are processes 1 and 2 and 3? So petroleum to saturated hydrocarbon. What is this? So petroleum or crude oil, as you may say, is melted, is heat, is in a liquid form, is fractional distillation of liquid crude oil takes place, in which different fractions of hydrocarbons form, which are then collected. So, and they are alkanes. From alkanes, to turn them into unsaturated hydrocarbon, we need what? We need to from long chain alkanes we can form alkenes, which are shorter chains, and they this is a process called cracking. This is just polymerization, in which many alkenes are joined together to form a polymer, and it can be plastic, nylon, different. So option C. The structure of a synthetic polymer is shown. So this is a polyamide, because this is an amide bond. This is amide bond. It is not an ester bond. The ester bond is this. This is an ester bond. So it is formed by which polymerization? Addition or condensation? So this is condensation, because this was originally C. This was the block here, COOH, and this was NH2. So this entirely made another additional product. So condensation, option B is correct. Which substance is a natural polymer? Protein, of course. Ethene is addition polymer, breaking the double bonds. Pterylene, same thing. Nylon is also a synthetic polymer. Only protein are made up of amino acids. So we have completed the paper. Jazakallah khair.